Okay, so June 2015 question on moments, question number 5. So this one says, diagram shows a plank of AB, mass 15, length 2.8 meters. Let's write this down so you go in. It's held in equilibrium. AB horizontal, held by 2 vertical ropes, one attached to the end A and the other attached to the end B. So that's these two things here, the ropes. A man of mass 80 kilograms stands at point C, where AC is 0.9. So let's put all the bits on before we read the question, okay? So we've got, let me just turn the lights back on. That. Got the rod, 2.8, they already put that on for us. Held in equilibrium. Man of mass 80, so we're going to put him down as 80G. AC 0.9, they already put that on for us. Now we need to read the question before we can put on the mass of the rod to find out. So modelling the plank as a uniform rod, find the tensions attached in the ropes attached to the end A and the end B. So 2 different tensions. So this time it's uniform. So that means the mass acts at the centre. There. Okay. So we know then that halfway across the rod is 1.4. So this part here is 1.4. This is 0.9. So 1.4 taking away 0.9 gives us 0.5 for that little part of it. Also know then we've got tensions in the 2 ropes, so they're going to act up. So I'm going to call this tension A and tension B. They could be called reaction A and reaction B as well. And there's our one set up ready to go. So to find the 2 tensions, we're just going to take moments again. Okay, anytime I mention the planks or rods, it's going to be moments. Now I'm going to take moments about A because that's going to eliminate the tension A. Because remember, moment equals force times distance. The distance here would be 0 to A, so that will eliminate that one. So I'm going to say moments, take moments about A. So moment is force times distance. It's in equilibrium, it's in the question. So we're going to have clockwise moments equal anti-clockwise moments. So let's start going from A. Force is putting it down, the clockwise one are 80G, distance to A, 0.9. 15G is coming down this way, distance to A, 1.4. That's the only 2 that are coming down like this. The ones that are going up, we've got the tension at A, but remember distance is 0, so you don't have to worry about that. We've also got the tension at B. Distance to A is the whole rod, which was 2.8. Then you're just going to work this out to find the tension at B. So calculating this gives you 705.6. This will give you 205.8, and then we got 2.8 TB. Adding these up, 2.8 TB divided by 2.8 tells us the TB is 325.5 newtons. And then we found the tension at B. Now to find the tension at A, if you've done moments already, then you need to look at resolving the forces in the vertical direction. So resolving vertically. This time it's an equilibrium again, so forces up equal forces down. Forces I've got going up are TA and TB. Forces going down, 80G and 15G. Okay, we know what TB is, so we can put that in. Adding these times by 9.8 times by 9.8, adding them up gives you 931. Take this over to find TA is 605.5 newtons. And there we have found the tension in the rope at end A and end B. Okay, part B then says, and I need some extra picture of this. The plank is now modelled as a non-uniform rod. Given that the tension in the rope at A is 5 times the tension at B, find the distance of the centre of mass. I don't think in centre of mass tables, all you've got to do, if it's non-uniform, that just means that the weight no longer acts at the centre. We don't know where the weight acts. That's what we're trying to find. So I'm going to redraw this diagram, okay, with my own little diagram, okay. So we've still got the tension at A, still got the tension at B. This time they're different because the mass is in a different place, okay. We've still got the man of ATG coming down here. Oh, I'm on there. We've still got this distance as 0.9. But the 15G, we don't know where it acts, the weight of the rod, because it's non-uniform. It doesn't mean it's in the middle, so it could be anywhere. So we'll just put it on this side here. Then we've got the distance. We're trying to find the distance of the centre of mass, so where this mass acts from A. So we're trying to find this distance here, which we'll call X. I think that's everything we've got. So to start off with this one then, what we can say, we've got tension A and tension in B. We know from the question, the tension at A is 5 times, the tension here is 5 times this one. So we can replace this, it's 1.5 times, sorry, 1.5 times this one. So we can replace this one with 1.5 TB. Because like I said, A is 5 times B. Then, because this is technically only one thing to work out, we can do resolving vertically. So I don't need any of that part. Let's look at this now. So we got forces up equals forces down. So we've got these two forces going up. Sorry, I keep writing the wrong thing. These two forces going up and these two forces going down. Collecting these up, we've got 2.5 TB. Collect those two up will give us 931. So to get TB, divide by 2.5, and that's going to give us 372.5. So we found the tension at B, but that's not what the question is asking us to do. What the question is asking us to do is to find this distance x. But the reason we needed those is so that we can then go on and take moments. Now again, I'm going to start taking moments at A, because I will again eliminate this need for this. So I'm going to take moments about A. So we've got clockwise equal moment equals anti-clockwise moments. So going from A, one's going clockwise are these two. So we've got 80G times 0.9 again, plus 15G times by the distance, which we don't know, is X, equals the one going anti-clockwise is this one, TB, times by the whole distance of the rod, which is still 2.8. Sorry, light's gone off again. Okay. Remember, we don't need this one because it was eliminated because we took it about A. Then all you've got to do is just work these parts out. So this is going to give us 15G is 147. TB, we know from here, you can put that in. Okay, then just work this out, take this over. Let me just work that out a second. So divide by 147, And that will give the answer of 2.29, so we can just say 2.3 metres there.